This is your host Swapnil Bhartiya, and welcome to another episode of TFiR Let's Talk. And today we have with us Benjamin Wilms, co-founder and CEO of Steadybit. Benjamin, it's great to have you on the show.
Thank you very much, and it's a pleasure for me.
Yeah, first of all, tell us a bit about the company itself, because your focus is, on chaos engineering and resiliency. That's also the platform that you recently released. But talk a bit about the company and your focus.
Steadybit is a chaos engineering platform, or maybe that's where we started in 2019. So founded in 2019. It's still, let's call it an early startup, because we were in total 11 people. And yeah, we started with chaos engineering, and then we learned with a lot from the feedback from our customers that, okay, chaos engineering is nice, but it's still like something you need to be an expert for, something where you need to know what you are doing, where you would like to start, how you start. And so that's a shift we have done with Steadybit. We are now able to help you to start at the right point in your system, to improve your system proactively, because we all know failure will happen all the time. So we are normally in this firefighter mode. We are normally like hunted by our own systems. There are incidents coming up again and again. But let's convert incidents into something where we can transform them maybe into an, let's call it regression test, where we are able to be more prepared for such moments.
So can you talk about the concept of chaos engineering in practice? Because the fact is that even if the word is chaos engineering, it's not chaotic. It's very well planned. It's very, very structured. That's also the place when most of the time a lot of companies, despite the fact that we are moving towards agile teams where everybody is aware of what's going on in the organization, sometimes when something bad happens, I think a very good example is Uber hack that happened, a few weeks ago.
Yeah.
That's when the whole team comes together. Hey, what happened? What went wrong? And that's when you see a lot of faces that you have never seen before. But chaos engineering tries to, do a lot of things. But chaos engineering is not, despite the name, that you're trying to change the wheel of your car while you're driving. It's very structured and planned. So talk a bit about the concept of chaos engineering. And once again, as you said, to prepare companies, what role does it play there?
So normally, if you are starting with chaos engineering, you will define some methods, you will define some principles on the internet. You can do a lot of research, you will gain a lot of knowledge, and then you will define something which is telling you, to do it right, you need to do it in production. So normally, because production is a living system, and normally you would like to optimize production. So it's correct. If you take a look at the books, you need to do it in production. But I'm a big believer that if you are starting a production, it's too late. You need to do it in an earlier stage. You need to do all the nice effects with chaos engineering in an early stage, so that developers, that SRE people, DevOps people can work collaboratively, hard word for German, to optimize the systems proactively and not just in production. So what you're doing when you're doing chaos engineering is you would like to find the unknowns. You would like to test your system. You would like to create experiments. So it's normally that you will start with an hypothesis that you would like to prove. For example, we need to survive an outage of specific services, or we need to survive high load under bad conditions, under maybe some latency errors in the network. And that's something where you would like to train yourself, where you would like to optimize your reaction time, your organization, your structure, and your processes.
Chaos engineering is kind of a term we have been hearing for, I think, before pandemic hit. It was initially just a concept. Then, of course, companies like Steadybit, emerged to kind of tackle that challenge there. Talk a bit about first of all, it's been a while there, and also, cloud native is a very new thing. Not that new, right? Kubernetes is only a couple of years old. But how have you seen the approach towards chaos engineering is also changed, and how kind of not essentially differentiate, but kind of set yourself apart from other players? What other values that you do bring to the ecosystem and market as compared to others?
Let me do just one step back, because it's important that you need to know everything started, of course, with some chaos monkeys, with some test script, with some simple shell script where people would like to kill a specific machine, would like to stop a specific machine, and then to learn and watch how my system is reacting. So that's that was been done. And then the Chaos Monkeys are coming up, provided by Netflix, and everything is now getting more and more attention and more traction. But that was a point where everything was done very randomly. And so it's not like that you can train a muscle, that you can repeat specific situations under control. And that was the shift, like, okay, we need to find a better method. We need to find some principles, how we should do it. That was the next logical step, why people have picked up chaos engineering or have taken care about how can we structure chaos engineering to get the most of it out of it. And what's the big difference with Steadybit? So you are only successful with optimization with help of chaos engineering experiments if you are able to close a gap. And the gap is between the SRE people, the DevOps people that are sitting in front of production. They are continuously hunted by production. They need to get production up and running, but they are continuously in this firefighter mode. And on the other side, there's this big group of developers, product engineering teams that are not measured on production uptime. They are measured on feature velocity. They need to get features into production as fast as possible. That's the biggest motivation. That's the biggest a goal they have to achieve. And on the other side, the smaller groups, the SRE DevOps people are, production is unstable, bad conditions, incidents coming up, security issues coming up. And then there is like 5,000 developers pushing into production with everything is automated. That's not a good place to be. And so we need to close this gap. We need to get people in the situation with Steadybit that SREs and DevOps people are able to use all the knowledge, all the experience, all the incidents they can see right now to hand over it to developers that they can use this data to optimize in their dev cycle in a very early stage. That's what we are doing with Steadybit.
Excellent, thanks. And also, when I do look at chaos engineering, it's less about tools and technology, it's also about the processes, how the teams actually work. And also in our industry, we like to kind of coin new terms. We talked about DevOps, then we talk about evolution, and now we start talking about cloud engineering or platform engineering. So the terms are also evolving and changing. Folks are like, hey, you know what? No, it's not. DevOps is gone. Now we are talking about platform engineering. But in reality, things are a bit same as well as different. There are teams who do specific things. So when it comes to chaos engineering, first of all, where does the buck stop? Whose responsibility it is?
There's a repeatable playbook we can see at our customer base. There's this expert group, platform teams, SRE teams, DevOps teams that are the early adopters, that are the people that are picking up chaos engineering because they need to get more time. They would like to get in a more proactive phase. They would like to optimize proactively the system, but it's not doable in the daily life. So how can we get more people on board? How can we convince developers that they have also take care about reliability issues and resilience in general? And to be honest, I'm also a developer by heart. So developers don't care about security. They don't care about resilience or reliability until there is a big issue, until someone is standing behind them, like there was this incident. And the last feature you have developed and implemented into production, that maybe was the root cause we have shown in the post-mortem analysis. And that's the point where developers are now, okay, I don't like to be in this situation, so maybe I need to be more proactive. And that's, the shift we can see.
Can you talk also about, within organizations, how much awareness are you seeing about chaos engineering is there? And once again, going to the point of culturally, what you're seeing, and once again, what companies are doing to have a culture of this preparedness versus finding something that, we were not even prepared about it.
So this early phase of chaos engineering, what is chaos engineering? What is it good for? It's done. People are able to understand that's a good way how we can do it. Now we need to figure out how we can do it in the organization, how we can roll out. So we don't need to educate people. For this specific problem, you need to do chaos engineering. No, it's already known by the people, so they are picking it up. And we can see it, for example, by one of our customers, Mano, an e-commerce platform. It's like they are searching for a problem, and they already know, okay, the best solution is to do chaos experiments, to do chaos engineering. So the education is done.
Right. Now let's talk about awareness also there. People are now looking at how to help. Can you talk about how StudyBit help them? If you can talk about the solutions, do you have services? Do you have software? How do you help folks?
As I started with SteadyBit, 3 years ago, in the phase before, I also started with open source tools. I also started with some existing solutions on the market. But then I learned like, okay, if I would like to do it in this specific setup, in this specific system, I need to get this open source solution and another one and another one. And now now I need to handle so many different parts. There needs to be a better solution. That's why I started to bring something up by my own, SteadyBit. And because how we are doing it is with SteadyBit, you can focus on your use case. You can focus on your stack, on your internal systems. You don't need to maintain thousands of tools to check if you are reliable or not. And with SteadyBit, you are installing agents in your system, and those agents are connected to one central platform. And the agents are continuously checking and scanning your system because your system is continuously in the changing mode. New instances are coming up, auto-scaling events, some moving parts. Kubernetes is doing some pod rescheduling, whatever. There are so many automations going on. That's something you need to understand and you need to see immediately. And that's what we are able to do with SteadyBit. So the agents are discovering your system continuously. And then you are able to run experiments. For example, you can start with an attack. You can select how you would like to test. Most of the times, the best trigger event is like there was an incident and you would like to replay a specific incident. So you can just drag and drop your components with SteadyBit, can execute the created experiment, and SteadyBit is able to tell you, okay, during the execution, we were able to identify in your Datadog, New Relic, Prometheus monitoring solution, we have identified there are some incidents coming up if we execute the specific test case. Or we can also collect automatically, if you're using Kubernetes events, so that you get a clear picture. What is my system healthy or not under those conditions? But that's just one part, because as I mentioned earlier, people are not the experts. People always asking like, where should I start and how should I start? What is my first perfect experiment looking like? And that's something we can help you. And it's not like that you are now starting with the experiment, with the attack. Now, with the help of SteadyBit, we can provide you a list of best practices. Like we have already checked your system. We have already discovered your system. And here's like a collection of test cases you should execute. You don't need to create them by your own. It's already done by SteadyBit. And that's like this big entry for people that not the experts for creating first experiments.
Excellent. Thank you. Now, you of course, you gave example of one customer. Do you have a lot of folks, large customer, small customer? Can you talk about, when you do work with those customers, what have you learned? Because, once again, chaos engineering is something, which you learn most in the field itself, because different companies, they have different problems. Different kind of infrastructure. They serve different kind of user base. They have different challenges.
Yes.
So, but that also helps you have building a pattern. We can help a wide, range of customers. So if you have, based on that, what you learned through your own customers and users, if you have any set of best practices or playbook, hey, this is the right way to approach chaos engineering. So you have some foundations in place.
There's a feature inside of SteadyBit which are exactly supporting you by that. So there is something, we call it a weak spot analyze. So it's something where you don't need to run an experiment, where you don't need to run a test. It's like just a check. It's like we have discovered, all this data is discovered by SteadyBit, and now we are able to point you to specific weak spots in your system without to run an experiment. And that's the first starting point. So in this area of my system, something is not working as it should. And that's a good starting point. That's where you can improve. That's where you can learn. And then the next logical step is to create an experiment to get more insights. And that's something we are able to do. And the next big learning is, as you might described it, every system is a tiny snowflake. So there are so many different parts inside of our customers. So we have a very nice mix of different types of customers, very large SaaS providers, e-commerce, some heating solutions manufacturers and insurance companies. And they are all using some cloud providers, some Kubernetes parts, but still they need to extend SteadyBit by their own. So that's why you can use our open source extension kit to write your own discovery components, to discover your system, to write your own attacks. Because we as Steadybit, we are not able to, let's say, write 10,000 of attacks or 10,000 of different discovery components. No, that's something you can do by your own. And that's something where we can see our customers would like to be part of this community, would like to contribute, and would also like to share their knowledge, their discovery components with others.
You, as you mentioned, open source. Talk about what is the importance of open source for Steadybit, and how much of your own work is already open sourced.
We started as a closed source solution, and the central platform which orchestrates everything is still a closed source solution. But I'm a big believer that you need to get your hands into the product as fast as possible. So you should do a sales call before you can try out the product. That's why we have a start free with Steadybit. So you can use our product, you can play around with the product, even if it's a closed solution. But then there are parts we are providing as open sourced. So there's one part like the extensions kits. You can create your own extensions. You can use existing extensions from the community. So there's no difference in the start free or in the paid version, so that you can experience the whole benefits from Steadybit. And another part is I talked about the concept of policies, the concept of weak spots. And weak spots and policies are also open source inside of Steadybit. So you can describe your expectations in code. And that's also something we have been make accessible as an open source way. So there are parts which are open source. The central platform is still in the closed source.
Benjamin, thank you so much for taking time out today. And of course, talk about chaos engineering, your own approach to it, sharing the platform, how it helps customers. And most importantly, that folks should have, resiliency or, chaos engineering strategy as part of their preparedness. So they're not caught off guard, because there's nothing worse. As you said, you're also a developer, and there's nothing worse than developers caught, hey, you know what? That's the problem. Now we are trying to figure it out. It does prepare. It doesn't kind of solve all the problem, but it does help in preparing companies to deal with a lot of challenges. Thanks for sharing those insights, and I would love to have you back on the show. Thank you.
Thank you very much. It was a pleasure.